Alright guys, welcome to this page of the notes, and again, what we wanted to do was we wanted to introduce you to two ideas in this set of notes. They were the tangent lines, which we just got done talking about. It is a line drawn so that it intersects the circle at exactly one point. That's what a tangent line is. The second thing we wanted to introduce you to was these circumscribed angles. Circumscribed angles and the circumscribed angle theorem. So first, what is a circumscribed angle? Well, I've got that described for you right here. I have a definition for the circumscribed angle. It is simply this. You take two tangent lines. I have two tangent lines here. How do I know they're tangent lines? Well, they're lines drawn so that they intersect the circle at exactly one point. What gives me the circumscribed angle is those tangent lines both originate from the exact same point, right? So they both have a common end point. So I pick a point, I draw tangent lines from that end point so that they intersect the circle at exactly one point, and what that gives me is this guy right here, a circumscribed angle. So this guy right here is my circumscribed angle. And we have a theorem for that, which we give you right here. So what the theorem says is that the circumscribed angle of a circle and its associated central angle must be supplementary. Say what? Here's what it says. Two ways to write it. I don't care which way you write it. Both are correct. Here's what it says. It says that the measure of angle x, this guy right here, my circumscribed angle, you could also write that as the measure of angle AXB, right? Whatever, right? AXB, it's that angle. Or just call it angle X, whatever. It's this guy right here. Then it says, right, that the measure the circumscribed angle and its associated central angle. Well, that's this guy right here, the central angle. We've talked about central angles in previous chapters, so that would be plus the measure of angle C. I could also call that the measure of angle ACB. Both acceptable names. I can either call it the measure angle C or ACB, whichever. They both mean the exact same thing. The theorem says they're supplementary, which means what? Well, that means that they have to sum to 180 degrees. All right? So both of these are saying the exact same thing, right? Angle X or angle AXB, same. Angle C, angle ACB, whatever, same. The idea is this: the circumscribed angle and its associated central angle must sum to 180 degrees. They must sum to 180 degrees. Okay, here we go. Now that we have that theorem, let's have you guys think about this a little bit. So, slide up here just enough to see my two questions, but so that I can still see my theorem. Here we go. I want you to prove that angle AXB and angle ACB are supplementary. We're actually going to prove this idea. And here's the way that we're going to do it. First, please notice I'm going to draw in boom. Please notice that that guy right there is a quadrilateral. How do I know that? It has four sides. So, A, C, B, X is a quadrilateral. Why is it a quadrilateral? Well, because it has four sides, right? Quadrilateral means four-sided figure. It's a four-sided figure. Well, I have a four-sided figure, and if you go back to, that's right, I know, going back, we go back to chapter 9. Fortunately, not as long ago as some of the other stuff we've done, but if you go back to chapter 9, we learned in chapter 9 that the internal angles, right, these four internal angles of a quadrilateral must sum to 360 degrees. So AXB is a quadrilateral, and we know that the measure of angle A plus the measure of angle C plus the measure of angle B plus the measure of angle X, right? I have four angles, A, C, B, and X, four angles inside my quadrilateral. Those four angles must sum together to 360 degrees, right? Again, all of that comes from Chapter 9, Properties of Quadrilaterals, Four-Sided Figures. Okay, great. Well, here, hang on a second. We just learned a second ago that when you have tangent lines and radiuses that intersect the tangent lines at the point of tangency, what do I know about angle A and angle B? I know they're 90 degrees. That guy has to be 90. That guy has to be 90. Okay, great. Here we go. So I have A is 90 degrees. I have B is 90 degrees, right? I'm going to subtract both of these guys to the other side. So 90 plus 90 is 180. I subtract 180 to the other side. I get the measure of angle C plus the measure of angle X must be equal to 360 minus 180, right? Because I take both these guys, I subtract them to the other side. 360 minus 180 is 180 degrees. And what you've just done is you have just proven that angle AXB and ACB must be supplementary. They have to sum to 180 degrees. How do I know? Well, angle A's got to be 90. Angle B has to be 90 degrees, so that means these two guys have to make up the other 180 degrees. They've got to sum to 180 degrees in order for this guy to be a quadrilateral. All right, so going back to what we learned in Chapter 9 about quadrilaterals and what we just learned in this chapter about tangent lines, our tangent radius theorem from the previous page, we can prove that the measure of angle C and the measure of angle X has to be 180 degrees. Okay, let me go ahead and erase that real quick. We need to answer yet another question. Here's what I want you to do. I want you to prove that AX and XB are congruent. Let me show you. Here's line XA or AX. Sorry, hang on, I went too far. There. AX, which you'll be in red, and XB, this guy right here, which will be in blue. I want you to prove that those two line segments are congruent. And I give you a hint. You'll do it using congruent triangles. Let me erase this so that I am not, so that you can clearly see what it is I'm writing here. Why is that not erasing? Oh, sorry. I may have already moved for some reason. All right, so here we go. Here's what I'm going to do. The hint is that you're going to use congruent triangles. Why is that a hint? Here's the reason it's a hint. We're going to go ahead and split this guy right down the middle there. What that gives me, right, is two triangles. I have this triangle up here, triangle AXC, and then I have triangle BXC. Okay, great. Well, here's what we've got. I already know, like we said before, I already know that the measure of angle A and the measure of angle B are congruent. I also know, right, that they share side XC and CX. So I know a couple of things. I know that the measure of angle A is congruent to the measure of angle B. I also know that XC is congruent to CX. That's what I know so far. Then what else do I know? Well, I know, right, radiuses. Check this out. AC is a radius, but so is CB. And it doesn't matter where you draw the radius in the circle. The radius of a circle will always be the same measure. Draw anywhere you want to. So I also know then that CA has to be congruent to CB. Okay guys, this goes back to, again, I know we're going back a ways, but we're going back to chapter 5, where we talked about congruent triangles. Sorry, I'm squeezing. We're going to go back to congruent triangles. In chapter 5, we talked about congruent triangles. We talked about a number of different shortcuts for proving that triangles were congruent. One of those being what we called CPCTC. Oh, sorry, hang on. Let's try again. CPCTC. Do you remember what that stood for? This stood for the corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. I know that these two triangles are congruent. How do I know? Well, I know because I have side angle, or angle side, right? Whatever theory, whichever way you want to say it. I know three parts of the triangle are congruent, therefore I know the triangles are congruent. So then CPCTC, corresponding parts of congruent triangles, must be congruent. What that tells me then is that XA or AX must be congruent to BX, right? This stuff right here proves these triangles are congruent. Since the triangles are congruent, corresponding parts must be congruent. AX is the corresponding part to BX, and so CPCTC tells me those guys must be congruent. So we've proven that AX and XB are congruent using congruent triangles. Again, going all the way back to chapter 5. I know it was a long time ago, but yes, still important information that you guys need to know. Again, the idea here in this lesson was simply to introduce you to two ideas we are going to use more later on. Tangent lines and then circumscribed angles, both of which are going to be very important in the next two sections when it comes to solving problems. So take some time. Consider these two ideas, tangent lines, circumscribed angles. I had a great time taking a look at it with you. I'll see you next time.